In this video, I'm going to go through how it is that we control confounding variables. So hopefully in the last video, I convinced you that confounding variables were an issue. It turns out that they're actually pretty hard to find. I find confounding variables in published papers in reputable journals all the time. So if you are going to be a good researcher, you need to know how to identify confounding variables, and also you need to know how to control or eliminate them. All right, so there's three different ways. And again, we're going to imagine that we're doing this alcohol and speech study where we've got a 0 drinks and a 2 drinks group. All right, so one way to control confounding variables is to do something called holding them constant. All right, so let's say, for example, that we're concerned that gender might be a confound of interest in our study. And we're concerned that somehow we're not going to be able to balance gender across the groups. And so we want to do something about this. Well, one easy way to control that confounding variable is to do what we would call hold them constant. So if we're concerned about gender, maybe we're going to only include one gender. So we'll only include females. So if we only have females in this group and we only have females in that group, then we have eliminated the confound of gender. The problem, of course, of doing it that way is that it affects generalization or generalizability. It affects, I really messed that up there. It affects generalization. So in the end, if it turns out that people that drink 2 drinks do worse than people that drink 0 drinks, well, we've only included females. So can we speak to what would happen in males if we haven't even used them in this study? All right, so we can hold them constant, but it's not the best solution. All right, the second solution is something that I like to call vary them systematically. And for this, I think the easiest way to do it is to just refer to this chart on the right. All right, so let's say, for example, that we identify a number of confounds that we're concerned about in this study. So let's say we're concerned about gender. Let's say we're concerned about age. Let's say we're concerned about weight. Okay, let's say for this study, we're only concerned about those 3 variables, gender, age, and weight. Actually, we'll add one more. Let's say we're concerned about medications, that we think people might be on some medications that affect their ability to process alcohol. All right, so let's start with the zero drinks and 2, let's start with gender, sorry. All right, so the way that we vary them systematically is we want to make sure that within each one of these categories that we have an equal number of people that fit these different confounds that we're concerned about. All right, so we're going to kind of do these one at a time. So we're going to start with gender. In order to vary gender systematically, what we're going to do is have an equal number of males and females in each group. All right, so we're going to have an equal number of males and females in the 0 drinks group and an equal number of males and females in the 2 drinks group. All right, so in this case, we've dealt with gender. Now we move on to age. So let's say we're just concerned with, we'll just break this into a dichotomy too, over the drinking age and under the drinking age. All right, so we want to make sure that within each one of these groups, we have an equal number of people under and over the drinking age. But we can't just add these 2 categories up here like we did with males and females. We actually have to embed this within the categories we already have. So in the 0 drinks group, we have to have an equal number of under 21 and 21 and over males, and same thing with females. So under 21, 21 and older. And then we have to do the same thing in the 2 drinks group. All right, so just with gender and age, we've taken a 2 category study into an 8 category study. Now let's move on to weight. Let's say we break it into 3 categories: underweight, average weight, overweight, because of course weight is going to affect how people process alcohol. Someone who's 90 pounds is going to get drunk a lot faster than someone who's 180 pounds. But again, we have to embed this into the categories we already have. So within the under 21 males, we have to have an equal number of people that are underweight, normal, and overweight. And we're going to have to do those 3 categories within each one of the categories we already have. I haven't even gotten to meds yet. And we have taken a very simple 2-group study into something that is just a monster. It's taken on a life of its own. So varying systematically is a good way if you're really concerned about controlling confounding variables, but it becomes super complicated. All right, so this is a generalization issue. Varying them systematically becomes super complicated, and you're going to need so many groups to carry it out that it's almost just not even worth it. Which brings us to the third and final way of controlling confounding variables, which is random assignment. And all that really means is that you are going to randomly place people into each treatment group. So you collect your sample of say 10 people or 20 people, and you're going to randomly assign them to the 0 drinks and the 2 drinks group. All right, so you could do that either by drawing their names out of a hat, by closing your eyes and pointing, just some way of doing a random number generator. Somehow you are going to randomly assign them to this group versus this group. And in theory, random assignment neutralizes or eliminates all of your confounding variables. So theoretically, random assignment is the best way to eliminate confounding variables. But as a researcher, I always still recommend that you double check and make sure, especially if you have a small sample size, that you double check and make sure that even though you used random assignment, that you didn't by accident include or still maintain a confounding variable like gender or something. So of these 3 ways, holding them constant, varying them systematically, random assignment. Random assignment is the best way of controlling it, but nothing in research is foolproof.